We're designing a new head for the OMAX water jet, and I need to make a prototype of this part for testing. It's designed as an aluminum part, so I want to make it out of a material with enough strength and stiffness that it could behave like aluminum during these tests. The machine shop's pretty busy right now, so taking a machine out of production for this is both slow and expensive, which is why we got a few Markforged machines available to keep my R&D efforts moving. In SOLIDWORKS 2020, I can open this file and simply go to File, Print 3D to check out how it's going to work. I'll start by choosing the printer I want to use. Now I've got my two machines in my favorites list. I've got a desktop Mark II and an industrial X7, but I can also create a custom printer or even grab one from the extensive library. We've been considering getting a Metal X to prototype steel parts, and we can kind of start to play around with the idea here before we commit to buying any hardware. This is a pretty big part. I figure it's probably going to require the X7, so I'll just grab that and select the face to orient the part, and it previews the print bed, and it looks like we've got plenty of room. Now, technically the X7 belongs to the machine shop to use for tooling, and the design team is supposed to be using that desktop printer we have in the office. So it seems like a tight fit, but if you do offset to geometry and orient to fit, it makes sure it's fully inside the printable area, and anything that won't fit is highlighted red, so it looks like we're just fine. I want to maximize the strength and minimize the amount of support required, so I'm going to jump over to the Preview tab, where I can check for faces that will require support, as well as set and preview the layer line heights to make sure I'm getting enough resolution around these holes and see how it's going to fit and land on various features. I'm worried about the sidewalls here being too weak in this area, and it's going to require a lot of support under these flanges. I'm going to see if we can use the back face orientation instead. Now, that requires a lot less support. There are some additional tools here available to actually set the slice settings, play around with other details, but once I've made sure that I can build this on this machine, I'd prefer to just jump into Eiger. So I'll save it as an STL file and add it into Eiger as a new part. I can configure the print settings to get the strength I need for this version of the prototype, something you can't really do with traditional manufacturing. I can make it a lightweight part with sparse fill for a cheap, fast prototype to make sure everything fits, all the way up to a solid part with continuous fiber reinforcement to better mimic the strength and stiffness of an aluminum part. I'd like to get this part built quickly, and I'm not concerned about deflection in this particular iteration, so I'll keep the default sparse settings enabled, and then I'm going to turn on turbo supports and turbo infil. This cuts the print time almost in half for this part without sacrificing surface finish or strength. Eiger calculates the material cost and time required automatically, and it slices on the cloud, so it isn't taking up my local resources while it calculates. The new Print 3D function in SOLIDWORKS gives me insight into manufacturability without requiring any data translation until I'm confident that I'm ready to print. And then once I get into Eiger, I can get my part set up and scheduled on an available printer to get it done as quick as possible.